Good afternoon and happy Thursday slash Friday because it's the last day of the week. Today we're going to be looking at limits at infinity. All right, I got a couple of options here. One of them we could be looking at the limit of a function as x approaches positive infinity, and that could equal L, which is just a generic number for limit. Or we could be looking at the limit as x approaches negative infinity, essentially as we're going to the left. We've got two possibilities. L could be a horizontal asymptote if it's a real number. And we're going to look at a couple of examples of that in a second. Or L could be infinity or negative infinity. So let's look at what I mean by that. So first off, you can see in this first picture, as the x approaches negative infinity to the left, it looks like we're leveling out at that -1 horizontal asymptote. Or as x is approaching positive infinity to the right, you can see that the graph is leveling off at that horizontal asymptote of +1. So that's what happens when you get whole number answers for these limits. Or you could get infinity or negative infinity. For example, as this graph is going to the left, or x is approaching negative infinity, the graph is getting higher and higher with no bound, so it would have a positive infinity limit. Same with to the right. As we go towards positive infinity, that's going up with no bound. Now, what would it look like if it went down? Well, it would just be that part of the graph could be switched. Maybe it looks like this. And now it's pointing towards negative infinity. All right, so let's take a look at some examples today. All right, first off, we want to find the limits as x approaches positive and negative infinity from a graph. So let's look at, a little thick on the pen there. Let's look at the limit as x approaches negative infinity of this function. And then let's also look at the limit as x approaches positive infinity for this function. It doesn't matter what the actual function is, I have a graph. So for the negative infinity, that means I'm looking at way out here. What's happening to the left? It looks like the graph is starting to flatten out at +1. So there's your limit. Nice whole number. That lets you know that there's a horizontal asymptote. Now how about as you're approaching infinity to the right? So over here to the far right, it looks like things are leveling out at that horizontal asymptote of 2. Right, so that would be some examples of your work. Nothing too hard when it's done from a graph. A little uglier when it's done without the graph. So let's look at this one, this messy one. We want to know what happens when the limit of t approaches to negative infinity. What's happening at the far left end of this graph? Now you could go onto Desmos or onto a graphing calculator and graph this mess and see what it looks like. That would be one option for you. Or we can learn how to do this algebraically. All right, so with the algebra portion, what we're going to do is we're going to first off look at the limits of the numerator and denominator, because maybe we get an answer that way. So let's try the limit as x approaches negative infinity for that numerator. All right, so for the numerator, if t becomes a negatively large number, even like a -1,000, well, you square that negative number, it turns back into a positive number. So the numerator is going to approach positive infinity. It's just going to keep getting bigger and bigger and bigger the closer you get to negative infinity. As the negative numbers get larger and larger, squaring them makes them a positive. Well, the denominator, same kind of thing happens. A negative number to the third power actually stays negative. And then add to that a negative number to the second power, which would be back to a positive. But again, the third power should give you a larger answer than the second power. So that denominator is also approaching an infinity, probably negative infinity. So that didn't really help. Sometimes we get like 0 over infinity, and we know the answer is 0 if you get a 0 in the numerator. Or sometimes you actually get numbers. Maybe they're both approaching the same thing. So in this case, we don't. So we need a strategy. What can we do to manipulate this equation a little bit to allow us to give some answers? So what we're going to do is we're going to essentially divide everything in the problem by the same number. So what we're going to do is we're going to divide by the highest power in the denominator. That's the key. All right, so it means everything in this formula is going to have to be divided by the highest power from the denominator, which is t to the third. Oops, an equal sign. So that means my numerator, which used to be t squared plus 2, gets divided by the highest power from the denominator, t to the third. And the denominator used to be t to the third plus t squared minus 1, and it also gets divided by the highest denominator, or highest power from the denominator. All right, what that's going to do is it's going to cancel some things out and turn some things into fractions, which will help us. It seems like it won't, but it will help us. So we're still looking at the limit as t approaches negative infinity. But again, let's do a little cleanup in this fraction. First off, on the left-hand side of the numerator here, t to the third, or second over t to the third, makes 1 over t. Then the second divide, 2 over t to the third, makes 2 over t to the third. Nothing I could do there. Now the denominator, I first have to divide these numbers, and they will reduce down to a nice whole number of 1. Now I'm dividing here, t squared over t to the third, just like in the numerator, that's 1 over t. And then here, just like in the numerator, there's nothing that can be done there. Now let's look at the limit as everything approaches negative infinity. So again, as t approaches negative infinity, what's happening in this fraction? So let's look at this first fraction here. As t approaches negative infinity, that means the denominator keeps getting bigger and bigger into this ridiculous number. So think about what's 1 over a million, or negative a million. Well, it's pretty darn essentially close to 0. And then the next fraction. Well, what's 2 over negative 1 million? That's also essentially close to 0. Now denominator, got a constant term of 1. Then the second fraction, denominator, that's the same as the fraction from the numerator. And again, 1 over a million is essentially close to 0. 0.00000000001 kind of a thing. And then in the back here, same thing. 1 over negative a million, doesn't really matter if it's negative or positive, that's also going to approach to 0. So let's clean that up. 0 plus 0, 1 plus 0 minus 0, and there's our answer. The limit of this particular function as t approaches negative infinity is 0. So that's telling us that we are going to have a horizontal asymptote right on the x-axis for this particular graph. That is useful information. Definitely useful information. All right, you only have 2 of these big nasty ones on your assignment today, and then a couple of the easier graph ones. Get a hold of me on the Zoom if you want to check an answer or you need any help. All right, good luck.